Okay, so the first one that we're going to talk about in terms of oxidizing alcohols are chromic acid and dichromic acid. And I actually have a special connection to these. When I was in high school, I worked with chromic and dichromic acid, and it was AP chemistry, so it was the first time I had taken like a real chemistry course. Because be honest with yourself, high school chemistry, even advanced chemistry, is not chemistry. Like it's chemistry 1, kind of that's it. So I was not, like most students, I walked in thinking, same hazards that are in advanced chemistry. And I went just like this at the lab with chromic acid on my fingers. Ended up giving myself a permanent sunburn that lasted for about 5 or 6 years. And actually, in my learner's permit, I actually am very red in the face because I'd done it just a few weeks beforehand. So, chromic acid does not mess around. In the presence of any alcohol, chromic acid will try to oxidize the carbon to its maximum oxidation state possible. Now, chromium can do this in 2 forms. The first is chromic acid, which is CrO4 as the parent acid, so H2CrO4. We can start with chromic acid, H2CrO4, or we can start with the potassium salt, potassium chromate, and then acidify it with H2SO4 and water. The second option is dichromic acid, Cr2O7, and I got that wrong there. We can either start with the acid, the H2Cr2O7, or we can start with the salt, the potassium dichromate, and add H2SO4 to H2O. Why would you start with the salts? Well, the salts are pretty cheap and easy to come by, and acids you're going to have to store as a liquid. So it's just kind of more efficient to work with the salt than anything else, and H2SO4, any reputable lab's got it. What's going to happen? In both cases, whether you're working with the chromic acid or the dichromic acid, you're going to take the alcohol and you're going to oxidize that carbon attached to it as much as possible. For a primary alcohol, something like ethanol, you're going to get the carboxylic acid. So primary alcohols in the presence of chromic acid or dichromic acid go to carboxylic acids. Now the thing is, these are good oxidizing agents, but they are not good enough to break carbon-carbon bonds. So in the case of something like 2-propanol, isopropanol, we can only go to the ketone because we can't break the carbon-carbon bond. If we get rid of the H here and the H here, we can form an oxygen-carbon double bond and get the ketone, but that's as far as we get. Now, let's say I gave you a tertiary alcohol, so tert-butanol. In this case, nothing's going to happen. And the reason why nothing's going to happen is that there is no way to increase the number of bonds between oxygen and carbon because there's no hydrogen to abstract on the carbon attached to the oxygen. So, in terms of tertiary alcohols, we're not going to see a reaction. For secondary alcohols, we're going to convert to the ketones, and for primary alcohols, we're going to convert ourselves to the carboxylic acids. Now, what if I want to form an aldehyde? Well, I can't do that with these compounds. These are far too aggressive. So, let's talk about the next video, a way we could take a primary alcohol and convert it to an aldehyde.